demonstrations are informing which technologies the service will invest in for the future. We have completed an analysis of alternatives and our acquisition team is working on the requirements. We are pretty deep into experimenting with hardware and software technologies that will help us control and exploit air power into the future, General James Holmes, Commander, Air Combat Command, told reporters at the Association of the Air Force Air, Space, and Cyber Conference. Part of the progress with the program, according to Air Force Acquisition Executive William Roper, is due to new methods of digital engineering. I have spent 6 months with our industry leaders and GUD team looking at examples of applied digital engineering. I'm impressed with what they have done, Roper. Digital engineering, as Roper explains it, brings what could be called a twofold advantage. It enables weapons developers to assess technologies, material configurations and aircraft models without needing to build all of them, all while paradoxically enabling builders to bend metal and start building prototypes earlier than would otherwise be possible. The reward is more than the risk, Roper said, speaking of the need to try something different and pursue newer acquisition methods which at times results in prototyping earlier in the process than the traditional process typically involves. The Air Force Research Laboratory has been working with the acquisition community on digital engineering techniques, often explored through modeling and simulation, for many years. Digital engineering is another exciting area and we see the opportunity to accelerate the pace of moving things from the bench level of science and technology into a system, integrating concepts into an operational campaign model, Tim Sekulik, Executive Lead for Implementing the Air Force S&T Strategy and Air Force Research Laboratory Lead for Materials and Manufacturing, told Warrior in an interview. Current work on a futuristic 6th-gen fighter, to come after and fly alongside upgraded F-35s, includes development of stealthy drone fighters, hypersonic flight, lasers, new precision weaponry and advanced AI-able organized targeting data in milliseconds. While all of these things are of course key parts of the equation, the Air Force Penetrating Counter-Air (GAD) program is equally focused on information exchange itself as a defining element of future war. Such an approach, looking beyond isolated systems and weapons themselves, envisions expansive networked combat with more platforms operating as nodes in a larger warfare system of weapons and sensors working together in real time. This approach is one that views military operations in terms of holistic elements of an information shooter-effector complex. That will require a lot more going into the design of the next generation of combat aircraft than how fast and far it can fly, or what the numbers of weapons it can carry, retired Lieutenant General David Deptula, former planner of the U.S. air attacks in Operation Desert Storm and current dean of the Mitchell Institute for Aerospace Studies, told Warrior Maven in an interview. The GAD program, which traces its history to the Air Force's Air Superiority 2030 flight plan, envisions the possibility of a family of capabilities. Holmes explained that this study began by examining more than 650 different ideas for 6th-gen combat, which were then narrowed down to merely a few. Directed by the Air Force Chief of Staff, service weapons developers who worked on the study have been working in Enterprise Capability Collaboration (ECCT) teams designed to pursue next-generation air superiority. We are moving into a future where aircraft need to be looked at as not just elements of their own, but as a system of information nodes, sensor, shooter, effectors. It is about creating an entire system of systems that is self-forming and self-healing with a greater degree of awareness than an adversary can achieve, and a much greater degree of survivability, Deptula said. Northrop Grumman, Lockheed Martin's Skunk Works and Boeing's Phantom Works are all among a handful of industry developers already working on prototype 6th-gen planes and advanced technologies, intended to align with key elements of the Air Force vision. The Air Force itself, while not yet decided upon a particular platform or fixed set of new technologies, is moving quickly beyond the conceptual realm into the active exploration of weapons, sensors, technologies and networks. There are maybe 2 to 3 companies that can build high-performance tactical aircraft, Roper said. Next-generation stealth technology is also, of course, a large focus of the technical equation. Newer radar-absorbing coating materials, improved IR suppressants or thermal signature management, evolved radar-eluding configurations and acoustic reduction technologies offer a window into current areas of developmental focus. A 2013 essay by the NATO Parliamentary Assembly Science and Technology Committee discusses the evolution of advanced heat reduction technologies built into the skin of an aircraft. To become low observable in multiple spectrums, advanced skins manage a plane's heat distribution to foil radar, infrared, and thermal detection systems. These skins do this by distorting or eliminating heat distribution to restructure its thermal shape. They may also be able to heat up or cool down all parts of an aircraft's surface to perfectly match the surrounding atmosphere, making it virtually undetectable. The report, titled The Future of Combat Aircraft, Toward a Sixth-Generation Aircraft, writes.